Hello, this is my Module 6 discussion post, and I will be reviewing the three samples that I drew from the GLUTE study, and I will be focusing on the impact of sample size within these samples of GLUTEs. So to start out with, my descriptive statistics include a sample size of 10, and then the mean was 10.92 pounds, and the standard deviation was 3.25 pounds, with the largest weight being 17 pounds, and then the lowest weight was 5 pounds, with a difference of 12 pounds. And to interpret this bar graph, we can say that yes, it is nearly normal because there's not an extreme skewness and there's no outliers. And I would consider this bimodal because there's two bars that are the highest, or around the same height on this graph, and it's pretty much symmetrical. And then we'll go to the second graph, or the second sample. And so this is a sample size of 40, and the mean of the specific GLUTE sample size is 12.93 pounds, and the standard deviation is 3.55 pounds. And the largest weight is 22 pounds, and the lowest is 4 pounds, with a difference of 18 pounds. And I would also consider this bimodal because of the two tallest bars. And there's also not many, these are kind of outliers, but I wouldn't say it's an extreme outlier. And there's also not an extreme skewness. So this is pretty much a nearly normal graph. And then for my third sample, which is a size of 160 GLUTEs, my mean is 12.66 pounds, and my standard deviation is 3.94 pounds, with the highest weight as 22 pounds and the lowest as 4, with a difference of 18 pounds. And I would describe this chart as pretty much unimodal. There's no obvious outliers or skewness to this graph, so we can say that yes, it is nearly normal. And then I'll go to my calculations as well. So for sample 1, I got the standard deviation of our statistic. So this amount is just saying that, or this is just a typical amount that a sample mean varies from population. So I divided the standard deviation by the square root of the sample size. And then for my lower limit, I got 8.6, and my upper limit, I got 13.2. And then for sample 2, I got 0.56 as my as the x bar, the standard deviation of our statistic. And then my lower limit, I got 11.8, and my upper limit, I got 14.0. And then sample 3, I got 0.31 as the x bar, and then lower limit 12.0, upper limit 13.2. And as you can see, so I did the rounding for the x bar, but then I included pretty much like all the numbers when I calculated the lower limit and upper limit, just to avoid rounding issues. And then from there, I will take you to my confidence interval and graph. So this is for sample 1, and I said we can be 95% confident that the average weight of all GLUTEs on planet Z is between 8.6 pounds and 13.2 pounds. And it got kind of cut off because there wasn't enough room. And at first I was kind of wondering why there wasn't more space, like lower, I guess, and I thought it was a calculation error, but I went over it a couple times, so if any of you see anything, if you would please let me know so I can correct that. That would be great. So I highlighted the confidence interval of what we know, or of what we are confident in, and like in between the two intervals. And then for my second confidence interval, we can be 95% confident that the average weight of all GLUTEs on planet Z is between 11.8 pounds and 14.0 pounds. And sorry, I forgot to mention, for sample 1, this is the sample size of 10, and then the sample size for this one is 40. So yeah, we can be 95% confident that the average weight of all GLUTEs on planet Z is between 11.8 pounds and 14 pounds. And you can see on this interval graph where I highlighted. And then for the sample 3, which was a sample size of 160 GLUTEs, we can be 95% confident that the average weight of all glutes on Planet Z is between 12.0 pounds and 13.2 pounds. And obviously the similarity in this is that they all use a 95% confident interval to see, or I guess to compare how confident we are in the interval and what the pounds, like the highest pounds and the lowest are, and then some differences. So I feel like I noticed that the smaller the sample size, the larger the difference of the confidence interval. And sample 3, when it was 160 glutes, or the sample size was 160, it got smaller, which I thought was really interesting. And it just kind of told me that the bigger the sample size, the less confidence interval or less difference in a confidence interval you will have. So as a researcher, I would definitely do sample number 3, just because I feel like it just tells you more by the confidence interval being smaller. Thank you.